Everyone. Good afternoon. Today I'm going to be talking about how AQR transformed our legacy monolithic engineering platform into an agile, scalable one running on AWS. AQR is a quantitative asset management firm. We are based in Greenwich, Connecticut, and we have roughly 128 billion of assets under management. Many years ago, we were, I would call, a traditional firm. We had a nice separation between research, portfolio implementation, trading, back office systems, nice API in front of all those things, sitting behind with databases, file systems, et cetera. And then as we started to grow as a firm, we started to sin a little. So developers, in order to break down barriers between teams, stopped using the API and started to go behind that API and started connecting to backend databases sitting behind them. And then that sinning continued. So as we grew as a firm and expanded, they kept going more and more behind the API until we had this incredibly tangled web and mess of interlocking dependencies across all of our applications. And our application development at that point was basically grinding to a halt as the company continued to expand. And so we were faced with a whole series of challenges. I've worked with many companies over my career, and I've experienced many of these at many of the different companies that I've worked for. AQR is the first one that hit all of them. And so I just want to call out some of the worst of the worst. One was all of the apps were tightly coupled together. So in order to make an application change, you really need to make a change to the backend database system. And when you did that and you had your customers talking to that backend database at the same time, you really couldn't make the change without breaking all of those downstream applications. So how did you make a change? You come in on the weekend, you kick everyone out of the pool, you make a change to your database, let's say a schema change, new table, new index, et cetera, and then tell all of your customers that they need to change their code at the same exact time. It was awful. The other problem that we had was a lot of legacy code issues. We had code bases that didn't have any owners. We have code bases that didn't have any unit tests. They didn't have any unit tests because, again, developers were sinning. They needed to get to market as quickly as possible. They were cutting corners and not doing any of these unit tests. This made them do the classic statement of when they tested in production. On top of all of this, we as an organization continued to grow. So our data footprint was doubling every 18 months. As a quantitative firm, we're constantly consuming more data, and the company was continuing to drive us forward. So we needed to do something. We needed some change. So we had this dream of, one, creating elasticity and scale, basically getting out of our on-premise data centers. And the other one was enabling what we call our citizen coders. So at AQR, as a quant firm, we have dedicated application developers that do application development for their job, but we also have teams outside of application development that do their own app dev. So biz dev does application development, our research team does application development, Pi does application development, and all of those people were basically stymied trying to use our platforms because they were effectively impossible to use. You needed to be an expert in database systems in order to connect to those databases, know what the data dictionary looked like, and know how to access all of that data. And they were effectively unable to do any of that. So our goal going forward was, one, solve the scaling problem by moving to the cloud, and then two, create a platform that is capable of engaging these citizen coders as well as our own application development team. So how do we do this? Well, one is we needed to get the firm on board. And that meant meeting with the chief risk officer and then doing what I call the AWS roadshow. So we went with all of the senior management of the firm. We met with all of them and convinced them that going to the cloud was what we needed to do as a business. And then we laid out all of the security and regulatory and operational procedures to operate in the cloud. And by doing this, really made the management team much more comfortable that we were operating in a safe and secure manner. And then defining data governance. So in that crazy web of a diagram that I showed previously, we didn't really have good curators of our data. Anyone could write to a database. It was terrible. So going forward, we said there's going to be clear owners of our data sets, and only those application owners can write to the data. Everyone else needs to use an API sitting in front of it, which led us to then defining business boundaries and application boundaries across teams, and then enforcing clear API contracts across those different teams so that they are no longer using those back-end systems. And we made that an engineering mandate. Basically, if you use the back-end systems instead of the API, you may find yourself on the chopping block. And so we couldn't move all of this at one time, so we picked up individual business processes and moved them instead. So instead of trying to move all of trade engineering and all of the applications that make up trading, we identified smaller processes like transaction cost analysis, a smaller application with less tendrils to other systems that we could pick up and move to this new platform. And then in order to make all of this work, we had to build the actual core tooling to make this new system and new platform build or happen. And so the first thing that we did is do this concept that we call X as a service. So we knew if we gave developers direct access to our AWS API, all they would do is take that mass tendril of all these crazy interlocking dependencies and then just move that to the cloud and then layer on 100 different AWS services on top of that and recreate the same problem except a magnitude worse. So instead, we, as the cloud engineering team, developed this paradigm of S3 as a service, Postgres as a service, Redis as a service, where we define the underlying architecture to run on the platform. So using S3 as an example, we define the bucket policy, encryption, replication to other regions, the tiering policy across different storage classes, et cetera. And then we make that all self-service for a developer. So we use ServiceNow at the firm. They go with ServiceNow. They fill out a form. Hey, I'd like an S3 bucket. Bucket name is going to be this. It's going to be in this production environment. I need this data retention policy, et cetera. They hit the go button. Underneath the covers are workflow fires, and that calls out to Service Catalog and CloudFormation and deploys the bucket for them. And then we found that developers, even continuing that same example with S3, even when they had the S3 bucket, they still struggled to connect to the bucket. They wanted that made as simple as possible. So they wanted simple things like, I want a get object function that I can pass a bucket name and a key into it and get the object out. And I want a put object function that just gives me the bucket name, key, and a file name, and I can upload the file. Underneath the covers, we wrote several libraries that make this all easy for them. So we're a Kerberos shop at AQR. We take a Kerberos ticket. We connect to ping fed. We exchange that Kerberos ticket for a SAML assertion, then take that SAML assertion, assume a role in AWS, get access keys and credentials, give that back to the calling client, make sure you're connected to all the appropriate proxies because we have tons of security at AQR. All of that undifferentiated lifting and all of that esoteric security-related functions is handled for the developer through all of these common libraries. And then we built them a platform so that they can do microservices and APIs for everything across the environment. We completely re-architected our infrastructure. So we moved from Windows-based machines to all Linux. We were previously stateful application servers, so data was actually stored on application servers. We moved to all stateless and ephemeral machines. We did everything as infrastructure as code. So AQR's footprint is a couple $1 million per month on AWS. We can't manage that scale that we're running without using infrastructure as code. So the entire infrastructure is defined in Git repos. If anyone wants to make a change to that infrastructure, it's a pull request followed by a peer review and then a deployment. No one has access to the AWS console to make any sort of direct changes. It is all done in code. We wanted to make the new environment more secure and more stable than running on-premise, and AWS provides a lot of tools to make that happen. And then support. We needed to continue to keep all of the legacy applications running. So the age-old saying of like, we needed to change the wings while the plane was in the air, that continued to be the case. We needed to make the platform as easy as possible for developers to use so that they would refuse or stop using that on-premise infrastructure and start using the cloud going forward. And then to further sweeten that deal, we created a dedicated team, which we call Platform Operations, whose job it is solely to help developers with any sort of infrastructure problem. Having a problem connecting to an S3 bucket, having a problem downloading a file, your build is failing, your deployment is failing. This is a dedicated team there specifically to help developers get out of working on an infrastructure issue and back to working on application development where they're actually adding value to the firm. And this took forever. I've been to several of the presentations so far, and I'm like, everyone is like building apps in 3 weeks. It's like amazing. We started in 2017, laying down policies and governance in those first roadshows. And now through the next 8 years, we have continued to develop those X as a service for our developers, sort of expanding their toolkit of what is available to build and operate on the cloud. We're now all the way today where we have Bedrock and knowledge bases and all that sexy new Gen AI stuff. So the results. So the first is a massive re-architecture of our system. We went from 2 primary data centers that operated all of our on-premise infrastructure. We are now down to 10 racks. That's it, 10 racks, predominantly filled with telecommunications equipment and 1 application that is multicast and won't move to the cloud. That means that whole aspects of our infrastructure team are no longer focused on infrastructure-related work. So capacity planning, fire drills, that constant upgrade cycle of new operating system, firmware upgrades, you name it. They're no longer working on that. Instead, they're working on things that actually improve developer velocity. We control the underlying infrastructure and framework, so everyone gets the same deployments, the same exact way across the firm. And that means less time fighting fires. We went from 10 Sev 1s on average per year, and by Sev 1 situations where we basically could not trade, a terrible environment, to now easily less than 1. It's been a long time. Users are now self-sufficient. So we talked about those citizen coders. Our application developers can work with the platform as well as people outside of the business. So we have people in biz dev, we have researchers, all developing their own applications on the platform and deploying them into production. This previously, for a developer to develop an application and then deploy it onto the platform, took 4 to 6 weeks. So after they were done with all of their software development and now wanted to hit the go button and to get deployed to prod, it was a 4 to 6 week process. And why that? So they took time to get a new server, application server, web server, DNS entry, firewall rules, load balancing VIP, SSL certificate. All of that stuff took forever to take care of. It is now down to less than an hour. They go to a ServiceNow form, they fill out the form, they get their Git repo. It has well-defined build plans for them for Jenkins. They make this a simple hello world application is ready for them. They hit the deploy button, their application is up and running. I'd like to tell you that we spend less money in AWS than we did on premise. We actually spend more. Per unit cost is lower in AWS for storage, compute, et cetera. But we're actually doing a lot more capacity-wise on the AWS platform than we ever were able to do on premise. So for instance, on premise, we used to be capacity constrained by a compute grid that was about 3,000 cores. We typically burst to 30,000 cores in AWS and easily consume all different types of CPU and GPUs. This is all done to reduce the pipeline required for our research team to be as small as possible. So our research team is there developing new signals. Those new signals then become tradable. They generate alpha for the firm, and that means money for ourselves and for our customers. We want that pipeline of ideas that our research has to be as short as possible so that we can get to that alpha period as quickly as we can. We were also constrained by the number of portfolio optimizations that we could do in a day. So a portfolio opt is where you take a portfolio, you apply our model to it, and then the output is whether or not we should buy and sell certain assets. It is extremely mathematically intensive because there's a lot of cross-correlation between the different assets. We were constrained on what we could do there. We can now do thousands of portfolio optimizations in one day. That allowed us to launch a new line of business. It's our new tax-aware long-short business, where we take portfolios from individual investors, and then we're optimizing each and every one of them. This new business was possible to get launched because of the new platform that we have available. It allows our citizen coders to then do the application development, to be part of the team that launched this new business, which is now 14 billion of assets under management. And then we've also introduced AI now into our systems. We, like many of you, have that chat-based API of help me write a letter and help me build a PowerPoint presentation. But we're now also using AI to generate new signals. And that really it's really only possible at AQR when we've unlocked the data that we have within our systems. Without that capability, AI really would not have been possible. So this transformation that we have gone through has really opened up the door to doing AI that wouldn't necessarily have ever happened in that old tangled web that we had. So in general, we went from a business and operations that was barely surviving into one that was thriving. And then just some final thoughts for anyone that's looking to do something like this in the future. Number one, I would expect, you should expect to have a lot of resistance. Even though you're going to the cloud and things are supposed to be better in the cloud, there's still plenty of people in the organization that love their servers, want to hug them, want to continue to be on premise, want to still log into a server, RDP, SSH into it, like it to have its name. They're going to be very resistant to ephemeral machines that exist for a few weeks and then get destroyed, which is the environment that we run into. My best advice there is to make the new environment as super simple, as easy to use, so that a developer would kind of be foolish to continue to run in the on-premise data center and much easier to run in AWS. The next thing that I would mention is minimal viable products. We're big fans of it at AQR. You could see in sort of that journey slide, we've gone over doing this, iterating over this for many years. We didn't just all lock ourselves in a room and then like deploy or come out 6 months later and deploying all of the AWS services. Instead, we deployed a service at a time and then continued to iterate based on that. And then last but not least, don't build when you can buy. So we have a lot of great partners at AQR, Sumo Logic, New Relic, ServiceNow, and of course AWS. And we outsource a great deal of our infrastructure to these partners. They do a fantastic job for us, and they really make it so that our infrastructure teams can focus on developing things for our developers that increase their velocity, and then in turn can add value back to the business. And that's it. I can open the floor up to questions. I'll also mention that I'll be around if you have questions and want to reach out. Talk to me one-on-one afterwards.